Okay, so first we have to read the problem. The problem says there is a 75 milliliter solution of hydrochloric acid with an unknown concentration, which is titrated to the equivalence point with a 23.7 milliliter solution of 0.157 molarity concentration of calcium oxide. Then they ask us what was the concentration of hydrogen chloride in the original solution. The first thing we need to know is that titrated to the equivalence point just means that all of this solution is going to react perfectly with the unknown concentration of HCl to form precipitate, and it means that all of this will react, so we will be able to know exactly how much of hydrochloric acid was originally there, so we will be able to find the concentration. So first we have to draw a picture of what a 75 milliliter solution of HCl would look like. So we know that it's 75 milliliters of hydrogen. Since it's a strong acid, we know that it completely dissolves. So we don't know how many moles there are because we don't know the concentration. But we know that the molarity is the moles per liter. Then we look at the second part of our problem. We have another solution, 23.7 milliliters. Okay, so we also had to draw a picture for the solution of calcium hydroxide. So we know that calcium has a charge of +2 and hydroxide has a charge of -1, since that's one of the polyatomic ions that we must know. So we know that for every one calcium ion, we must have 2 hydroxide ions so that the charges will cancel out. So we know that the molarity is 0.157 for this solution because that's what the problem tells us right here. And we also know that molarity is moles per liter. About what we know. We know that the volume for calcium hydroxide is 23.7 milliliters and that the molarity for calcium hydroxide is 0.157. This is for calcium hydroxide. We also know that the volume for hydrochloric acid is 75 milliliters and we're looking for the molarity, right? So hydrochloric acid. And we know that all of this calcium hydroxide will completely react with whatever amount we have of hydrogen chloride. So here we have the balance equation, 2 hydrochloric acid molecules for every 1 calcium hydroxide. Molarity equals moles per liter. We know that we can find the moles of calcium hydroxide because we have both results. But first we have to convert 23.7 milliliters to liters. We know that there's 1,000 milliliters for every liter, so we convert to liters and we multiply by the molarity and that will give us the moles. Okay, so using our calculator we figure out that we have this many moles of calcium hydroxide in our solution. So since we know how many moles of calcium hydroxide, we know we can go back to figure out how many moles of hydrogen chloride we reacted with by using the stoichiometry of our equation. Remember I told you we get 2 moles of hydrogen chloride for every 1 mole of calcium hydroxide. So we use these numbers as a conversion factor. So we set up our equation. So 0.003729 moles of calcium hydroxide times, so 1 mole of calcium hydroxide for every 2 moles of hydrochloric acid. So moles of calcium hydroxide cancel out. Okay, so using our calculator, we multiplied these 2 numbers together and we found out that we have these many moles of hydrochloric acid in our original 75 milliliter solution. First of all, we know that with moles and liters, we can figure out the molarity, which is what our original equation is asking us. What was the original concentration of HCl? This is what they're asking. So we know that with the moles of hydrochloric acid and the volume, we can figure out the molarity. So we set up our equation. First, we have to convert 75 milliliters to liters. As I said, there's 1,000 milliliters for every liter. So we have 0.075 liters. And we have these many moles, so moles of HCl. And we know that our equation is molarity equals moles over liter. So we put 0.0074418 mole of HCl over 0.075 liters. That will give us our unknown molarity. So using our calculator, we find out that this equals 0.099224 moles. So our original concentration for hydrochloric acid was 0.099224. Mistakes that you should watch out for is many people forget to convert milliliters to liters. You have to be very careful with your units because the formula specifically states that it's over that molarity is per liter and not per milliliter. So always convert to milliliters. And also always remember that you can use the stoichiometry to go from moles of one molecule to moles of the other molecule. You can't use the V1 M1 times V2 M2 to figure out what the concentration is because we're not talking about the same units per se. We're not talking about moles of calcium hydroxide and moles of calcium hydroxide. We're talking about two different molecules, and therefore the amounts because of this stoichiometry will be different.